Hello, my name is Luis Serrano and this video is about the receiver operating characteristic or ROC curve. The ROC curve is used widely to evaluate machine learning models and make important decisions. First, let's say we have a data set of blue and red points where the blue points are labeled positive and the red points are labeled negative. Now we proceed to build a machine learning model that fits this data set, for example this line. Notice that this line has a blue and a red side, indicating that every point in the blue side is classified as blue or positive, and every point in the red side is classified as red or negative. Notice that the model makes some mistakes. One of them is this red point, which is above the line or on the blue area, and another one is this blue point, which is below the line or on the red area. These errors have names. Since the red point is a negatively labeled point, yet it's predicted positive, it's called a false positive. And since the blue point is a positively labeled point, yet it's predicted negative, we call it a false negative. If you wish to learn more about false negatives and false positives, check out this other video in my channel called Machine Learning, Testing and Error Metrics. The link is in the description. Now let's actually think of these two different examples for the same type of model. The model in the left will be a medical model where the positive points are the sick patients and the negative points are the healthy ones. And the model on the right will be a spam detection model where the positive points are the spam messages and the negative points are the good messages or non-spam, also called ham. Now we can see what the false positives and negatives look in each model. In the medical model, a false positive is a healthy person which is diagnosed as sick, so they may be sent for more tests. A false negative is a sick person which is diagnosed as healthy, so they don't receive any more treatment and they are sent home. Let's think, which one of these two is worse? Well, I think it's the false negative, since I'd much rather send a healthy person for extra tests than send a sick person home. So let's forget about the false positives and try to modify this model so that it won't have any false positives at all. Something we can do is translate the line down here to make sure our model makes no false negative mistakes. Now what about the spam model? Well, the false positives here are the good ham emails which are classified as spam, so they are sent to the spam folder, and the false negatives are the spam emails that are incorrectly classified as ham, so they're sent to our inbox. And again, which one is worse here? Well, I'd much rather have the occasional spam email in my inbox than have my good ham emails deleted. Therefore, this model is different than the medical model. In this one, our goal is to have no false positives. So we can forget about the false negatives and then look at how to modify this model. Well, what we can do is translate the line up so that we have no false positive errors. Now these two models are extremes. Most models are somewhere in between the two. They will be okay with some false positives and with some false negatives, but they may still consider one of them more important than the other one. That means for each type of model, we have to decide where is the perfect point to translate this line. And in this video, I will show you a very useful method that helps us take this kind of decisions. Now imagine that this is our data and this is our model. Actually, all our models are going to be parallel translations of this line. For each of the models, we're going to record two numbers, the number of correct red points and the correct blue points. So when the line is down here, how many correct blue and red points do we have? Well, notice that the line has blue on top and red on the bottom, so it classifies anything above as blue and anything below as red. Therefore, none of the red points are classified correctly, and 5 blue points, which means all of them, are classified correctly, so we have 0 and 5. We record the 0 and 5 in this table here, and then we plot them in the graph at the right as this point over here. Next, we translate the line a little bit until it goes over one of the points. And now we do the same thing. How many correct red and blue points do we have? Well, there's one point red in the bottom of the curve that used to be classified incorrectly and now is classified correctly, and all the rest are the same. So we still have 5 blue points correct and 1 red point correct, so we have 1, 5, and we plot it here. And we continue in this fashion, always going over one point and plotting that. Sometimes we will increase and sometimes we will decrease, and we continue until the very end. Now notice that at the very end we're in the opposite situation. all our red points are classified correctly because they're on the red side, but all of our blue points are classified incorrectly because they're on the red side. So we're always going to finish in 5, 0. And this is very important. We always start at 0, 5 and finish in 5, 0. The next thing we do is we draw this curve. And then we calculate the area under the curve. This one is 21 squares. We actually care more about the proportion. It's 21 divided by a total of 25 squares. So we have 0.84. That's the area under the curve. Note that this area can be between 0 and 1. And if you look at it carefully, the better the model, the higher the area would be. This is something that we're going to see more in detail later. Now here's the interesting part. We can use this ROC curve to make decisions about our model. A good model, for example, would be this point over here and which correspond to this line, which doesn't make too many errors, false positive or false negative. A model like the medical model, which wants very few false negatives, could go over here, and a model like the spam detection model, which wants very few false positives, could go over here. So depending on what our interests are, we can look at this curve and pick the point where we want the model to go. We can also look at it from a different angle. Let's say that these are all data points, and notice that the model scored all of these with some value from 0 to 1, and this is a decent model because it scored for the red points, give them a low score, and the blue points, you give them a high score. However, we need to turn this into the discrete prediction, which is yes or no, positive or negative. Therefore, what we have to do is we have to put a threshold between 0 and 1 and say everything above this threshold is going to be predicted as 1 and everything below this threshold will be predicted as 0. And notice that that's equivalent to translating the line up and down, because what we're doing is we are giving it a different threshold for the predictions. Now to make this easier, let's plot the density of red and blue, namely how many points are there. And as we move the threshold just like before, we notice that since the model classified the ones to the right of this vertical line as blue and those to the right as left, then at the very left all the blue are correct and all the red are wrong. As we move towards the right, more red are correct and less blue are correct. And so we are drawing this ROC curve that we see on the right. And finally, depending on our problem, we make a decision. Let's say we care just as much about false positive and false negatives, then this seems like this point over here would be the happy point, which makes as few errors as possible, so we pick down. And that one corresponds to a threshold of 0.65. So thus in our model, we're going to predict anything with an output of 0.65 or more as positive, and anything with an output less than that as negative. And so what the ROC curve records is a movie of all these possible thresholds and how they do. So by taking a good point in the ROC curve, we can pick a good threshold. Now before we mentioned that the larger the area under the curve, the better the model. I'll elaborate here. Notice that this model over here does not classify the data very well, no matter how much you translate it. It always seems to have half of the points right and half the points wrong. This model is almost as good as a random classifier, and its area is close to 0.5. When we have such a model that gives an area under the curve of about 1/2, we say that this model is almost as good as a classifier that randomly picks a class for every point, so it's not good. The second model over here is a bit better. Notice that when we calculate the area, it has an area under the curve of 0.8. And finally, this classifier over here is perfect because it manages to get an area under the curve of 1. What does that mean? Well, it means that this classifier has some translation which classifies the data perfectly. And that corresponds to this happy point over here, where all the blue points and the red points are classified correctly and there are 0 mistakes. Now, what about models in which the area under the curve is less than 0.5? Well, surprisingly, those are good models again. Let's say we have a model so terrible that the area under the curve is 0. That corresponds to this. But a model that makes all the mistakes is very close to a model that makes no mistakes, simply by flipping all the predictions. This is equivalent to switching the blue and red labels in this line, or equivalently, rotating it 180 degrees. And that's all, folks. Thank you very much for your attention. I'd like to remind you that I have a book called Rocking Machine Learning, in which I explain the algorithms of supervised learning and some very important machine learning techniques with Python code. You can get it on manning.com, and if you use this discount code SerranoYT, you can get a 40% discount. If you like this video, please subscribe for more content, hit like, or share it amongst your friends, and please comment. I love to read the comments, especially if you have any suggestions for other videos you'd like to see. If you'd like to tweet at me, this is my Twitter handle, Lewis Likes Math, and check out this webpage, Serrano Academy, where you can find all this information about videos, book, courses, etc. Thank you, and see you in the next video.